You will let me know once the streaming is started, right? So that I can get started.
Perfect, it started.
Okay. Hey, good morning, good evening, depending on where you are. Welcome to Uttar Pradesh Power BI Club. I can get started on today's session. So this is our Microsoft Fabric Thursday series. Thanks for inviting me to share some of my research and findings on this platform. Appreciate you guys having me and joining up for these sessions. I will go through the presentation. You can share the questions. I'll answer as much as I can, depending on how the time permits. But I'll try to answer everything if any questions are coming my way. So today's session is Agentic AI in action. So it's more on like scalable architectures and workflows for the enterprise. This is more from an enterprise standpoint. There are different Agentic AI systems. I'll go through them, but I'll take it from an enterprise perspective, how to build Agentic AI systems. Yeah, that would be the talk for today. It's more leaning towards an enterprise, and I'll cover from basics a little bit. I'll spend a little bit time on setting that platform up in a sense like what's an agent, what's an agentic AI versus what are agents, AI agents. So there are different terminologies going around. So we'll get that started. So briefly about myself, my name is Manoj Jekavarapu. I'm a senior director here at Progress Residential. It's one of the leading SFR single family rental companies in US. So I have close to 21 years of experience. I've been building enterprise systems for a while. And especially in the last 7 years, I've done multiple implementations or leverage AI systems to build products and took them to market, as well as I'm also other area that I'm an expert in is cloud architecture. So I have a lot of experience migrating in-house workloads from on-premises to cloud. One of it being like we kind of migrated the whole 7-Eleven store systems into cloud. So it was like 12,000 store systems going into cloud, handling that scale, right? From an AI ML workloads, throughout in the last 7 years, I've worked on multiple things. So initially worked with NEC, took their facial recognition system, used it for loyalty and payments. So that was, and we created something called like we partnered with a company called Pop ID and created a Pop ID for loyalty system and payment system using face for retail, right? So it was the first thing. So before even that was even before the facial payment became a thing on Apple Pay and Google Pay, and like we walk in, you recognize. So for loyalty points as well as payment, right? And then at 7-Eleven, I also participated in cashierless version. Like it's a second round of our cashierless store. It's basically on the lines of Amazon Go. We built that system. I supported the application systems building that part, so leveraging a lot of AI ML systems there. But it's more like from an application standpoint, right? Like enterprise applications standpoint. And in the current role, I've been working. I'm responsible for AI automations that includes RPA and all the other AI initiatives. So RPA, we've done a lot of automations, but in AI, like we recently implemented 2 agentic systems. One was lead nurture journey. I can talk through it if you have any questions, but it's more like when a lead comes in, providing them the nurture journey, cadence messaging, answering their questions on any questions that they have, all that stuff. And then recently we implemented a knowledge management system as well. It's more like, and this was implemented using some of the RAG architectures for supporting our resident virtual leasing assistant as well as virtual resident assistant. So we're building a lot of stuff and learning a lot of things while building AI systems and especially AI agent. Then, so coming to today's agenda for this topic, as I said, I'll cover the introduction to Agentic AI and what components of the Agentic AI system are. And when we cover those components, we will see a lot of things. How do we coordinate between them? What are the real world applications in enterprises? What are the operational workflows, performance gains, and some of the ethical and governance constraints? How do we going forward adapt them and any question and answers at the end of it? Okay. So primarily, what is Agentic AI? Again, this term kind of became popular in the last 1.5 year, and there are different variations of it. We have Agentic AI systems. There's AI agents. What is the difference between AI agents and Agentic AI system? Or what is it? What are AI agents and what are Agentic AI? Right. And before going there, I'll just take a couple of minutes to level set on what an agent is, right? And then go from there, right? So the term became popular like in like 2 years back. This whole LLM just became that LLM revolution happened, right? So we have OpenAI came with the model. So it was trained on a pre-trained data set, but then that was the initial thing, right? You ask it, it was very good at summarizing things. So it was like more of a question answer mode. And then how things evolved and they started training, the model providers started training the models on, hey, can I provide additional capabilities, right? And like the first capability that was provided or became a product is perplexity, right? So agents, the LLMs are trained on the whole internet, but they have a cutoff date. Right? But if you ask it something, but it's responding with the recent information. How is it doing that? Is tool addition capability. So they were given tools. So one of the first tool or the most important tool that was given was the search capability. So it has like it's like our brain. It has learned something, but there is only a certain amount of information that it could act on, bringing it into its context. So the search capability was given so it could know, okay, the user is asking about something that I do not know, but I have this capability to go and search on the web. So I'll search on the web and get that information, pull it into my context, and answer all these questions. Right? So similarly, that's where this whole agents were born. So if you think as what's an agent is, in like it's similar to how any agent that we deal with, whether we're booking systems or anything like that, right? An agent has thinking capabilities as well as they have some tools to get their work done. So that's fundamentally what an agent is, what an AI agent is, right? So the thinking is the LLM part of it because it can act as a brain for the functionality. It's pre-trained on certain things. Now you're giving capability and how you manage that context via prompt engineering or providing additional information into that context. It's able to use that information and achieve a goal that you're looking at, right? So that's what an AI agent is, right? So that's the baseline definition of what an AI agent is. It has a brain and it has tools, access to tools that it can do, like a human, like we have brain and hands and legs to do different things. So that's the and we use different tools depending on the task, right? So based on that, that's an AI agent. Now, what's an agentic AI system? So So what's an agentic system, AI system is primarily, the way you look at it is, I'll take an analogy and try to explain it. That way, it will be more helpful. So let's say you're running a restaurant, right? So there are like a big restaurant. There are cooks and there are executive chefs, right? The cooks are who are like, hey, make this dish. You are, yeah, they're cooked to order. The cook will take that dish. Once the order comes, they'll cook depending on the specifications, mild, medium, or spicy, whatever that is, and whatever ingredients you have to swap. They are executing that part, right? So in that sense, they are AI agents. If you look at that model. But if you look at another concept, like if you go a little bit higher, there are these executive chefs. Uh, they are planning for the whole thing. They're just not looking at cooking one dish, but they are trying to run the whole restaurant itself, right? So they have to plan the menus. They have to plan to manage the inventory. If something is getting expensive, how can they change the dishes? They have to strategically adjust their menus based on seasonal ingredients, whatever customer preferences are. So that's like an executive chef who is handling more than just ordering uh, or cooking one dish, right? So that's what an agentic AI system is. It's more like it's doing one functionality or a big functionality end to end. And in real world, a good agentic AI implementation that we all are aware of is self-driving cars. So, like, I'll at the end of it, I'll briefly cover it. Uh, uh, how self-driving car is a good agentic AI system, but that's because it is able to do a lot of things. It's able to do sensor fusion. Uh, it's able to stop, brake, steer, and plan the journey, plan it on fuel, all that stuff, right? So that's a great agentic AI implementation that we have today in real life is the what do you call the self-driving systems, self-driving cars. Okay? So now, why agentic AI for enterprises, right? So agentic AI for enterprises is like enterprises have also evolved. Like if you look at how things have changed. So initially they were like RPA was a big thing. Like oh we have an RPA. Let's use it to mimic users and try to do scripted automation, right? Uh, but they are not like adaptive or context aware. So what happens is like if you take some real world examples, an RPA system can be like, hey, if the claim is less than $500, auto approve, right? But it doesn't. So it's a rule based system. It's heuristic. So there are like a lot of rules that it follows. But you can easily kind of submit multiple claims under 500, and you can kind of technically, it is not context aware. You can technically cheat that system, but you have to build a lot of rules to prevent that. But again, in its simplest form, it's like that, right? So RPA is trying to automate how a user does things. It is trying to mimic, hey, user goes to this page, clicks on this, let's automate that, or kind of build other UI automation, right? UI automations are behind the scene automation, but RPA was more for UI automations, because behind the scenes, if it was data moving from one database to another database, they were, again, bad jobs were already doing that. But the core piece was mostly like RPA, right? But that is not context aware. It doesn't have the intelligence. It is you have to build a lot of rules aware system, right? So that's where it is. That's why when with the leverage and enterprises were trying to solve this problem for a while. So there were implementations on AI and ML kind of things. There were a lot of training needs to be done, and some of the implementations were enterprise systems were chatbots or some kind of training things, but it was very expensive in the sense like you have to train it on the. So I don't like if anyone has built an ML pipeline, you will know that you take the set, you divide it, you have to train it off, you take it for training, you run the results, and the pipeline building of that workload is very time consuming and expensive process, right? But what LLMs kind of did, what they revolutionized is when LLMs came, the capability that they unlocked are like, hey, I have a brain kind of a functionality, I have a thinking capability. I am trained on the whole internet. I can give you a like I can act with that intelligence, right? I can decide things for you. I can recommend things for you, but it's not AGI. We are far from AGI, but they have that capability. If you give it enough context, it's like, hey, I know how things work, but if you give me that and like if you tell me that exact scene, then I can tell you what movie it is. But I kind of cannot tell you by myself what movie you're thinking about. But if you give me more context around it, I can tell you, or I can ask you, I can help you do things around it, right? So that's what LLMs unlocked. So with this, what happened was like on enterprise side, it kind of is revolutionized a lot of things. So we are looking right now to start automating a lot of stuff so that all the mundane things can be done and the productivity gets improved across the enterprise, right? So, and agentic, like as I said, even in enterprise also, depending on the level of the enterprise and their teams and their investment into this infrastructure or into this capability building, there are teams that are just building AI agents. There are teams that are building agentic systems, right? So, but it's an evolution. You won't start building right away agentic AI. You'll start build an AI agent, and you will figure out what are the challenges of running into it. The other part of it is uh, all these any AI ML workload is non-deterministic by nature. By that, what I mean is like LLMs also, right? If you ask the same question multiple times, it can give you multiple different responses every time. And in some industries, it won't work. In some industries, it's okay, right? Depending on the workload. Again, a lot of context around which workload that we are building, what is the problem that we are trying to solve, what are the regulatory compliance activities around it, right? So agentic AI for enterprises is, hey, let's move beyond the RPA, scripted automations, and rules. Let's see if we can build adaptive, context-aware intelligence. For example, the other example I can give you is like chatbots. Previously, chatbots were trained on rules, how to communicate, how to do, but right now you're just telling it to say, hey, prompt, you're a chatbot, you be respectful. This is your tool. If someone is calling around a payment issue or an order issue, go and use this tool to get the other details so that you're pulling in that context on the fly. You're not spending your energy training the chatbot. You're spending that energy providing the context, which is more important because that functionality is already pre-trained in the GPT, right? That capability is given to us by the LLM calls. And then so that's how the agentic AI systems are coming into the enterprise, right? Now, and now coming to the core concept of this talk, it's more like what are the core components of an agentic AI system, and building, as I said, the AI agents are one evolution ahead. Like the initial is like you make a call, you get the response, you generate text, great, but that's humans doing. You build your first agent, you're leveraging the LLM, you're giving it tool capabilities. But again, like if you want to build a virtual uh, resident assistant in our rental business, or different things, right? How do you build those things? And this talk is trying to get you a framework on how you can build these components, right? So and the way I like from a metaphoric standpoint, the way I look at it, this is how think of these as like essential organs of an like agentic system, right? So the things that I've listed it here are more like perception modules, planning engines, decision frameworks, adaptive learning loops, execution systems. So these things, I'll cover each of these, but think of them as like, hey, these are like essential organs of an agentic system. Like if you want to build a good agentic system, a functional agentic system, an enterprise scalable agentic system, this is the framework that you need to use. Is like it should have perception modules. I'll cover what they are. It should have a planning thing. It should make decisions. To make decisions, it needs a framework. And once it makes some decisions, whether it worked, not worked, there's a feedback loop that needs to be done so that it kind of learns and knows that, okay, that decision didn't work, and it can learn on the fly and execute the things that we actually want it to do, right? So these are the 5 things that are important for building a good agentic AI system. We'll cover each of these, and I'll cover like each of these and give you a context of what these would look like in real life scenarios from an agentic system standpoint. Right. So the first one is first key component of a good agentic AI system is perception modules. So perception modules, like it's like your sensory organs, right? You're perceiving things, but you're just not looking at things, but also you're trying to understand the context behind it. So if you look at it, perception is like how agents understand that environment that they are working in. It's just not data, but what's the context? Okay, so that is important. So the perception module covers plays a role in the agentic AI system, telling the agents like, hey, this is just not data, but understand the context around it, right? If you take a real life example, in a customer service agent, perception modules are not just processing the words on what a ticket was, but also they have the capability to look at a customer's history, sentiment, and depending on the text, what is the urgency, the customer, like trying to understand when a ticket comes in, when a customer support ticket comes in, what is the urgency around it, right? Not all tickets are not equal. Some will have an higher priority, some will have lower priority, right? So you're trying to determine the urgency of it. The customers can tell it's very urgent or it's like catastrophic, but you're trying to determine that so that you can deploy the resources that you have judicially at solving that problem, right? And what the current status is like, if it's a duplicate issue, already raised it, they're rechecking it, whether it's a status check on it or a fix has happened and it's reoccurring. So it's there's a lot of variations of it, right? So these perception modules can handle structured data, unstructured data, real-time sensor feeds, depending on the system that you are building. They are like, in some systems it might be as simple as text, in some systems it might be a sensor fusion, like multiple sensors coming into place. And in some systems it might be text or a combination of this, right? Like a multimodal approach can also be done. Like, for example, if you are looking at uh, a customer support ticket, if they send some photos, now you're looking at, okay, photos or videos, you're trying to parse it and you're trying to get the text of it and try to understand the context around it, right? So number one is perception modules, right? Agentic AI system will always have perception modules around it. And then second is planning. The second core component is planning engines, right? So what is a planning engine? So the way I would look at planning engines are like, these are like strategic thinking components of an agentic AI. So for example, right? Like if we take an example, this will become clear. Let's say, and we all know the delivery things, right? Like we order things, we get deliveries. And how do they plan the delivery, right? And this happened to me as recently as yesterday. We we ordered something. We got like 3 pairs of shoes. Didn't like any of those. We processed the return, right? I was expecting one person will come and pick up those all three things together. These are 3 pairs of shoes. They are not like different objects or a different size objects, right? They are exactly the same. Very simple, like a pair of shoes, 3 pair of shoes, right? And to my surprise, 3 people came within a period of 10 minutes and each collected one pair each. And this happened to me yesterday. I was kind of surprised in a sense, like which route optimization engine uh, made them do this, and whoever processed that, or like I didn't process. Uh, it was part of one order. We set up return on the same order, but again, 3 people came. 3 people came to pick up 3 pair of shoes, which were part of one order, right? So what went wrong there? What went wrong there is the route optimization. It optimized which parameter it optimized for. I'm still trying to understand which parameter it optimized for, right? So when you're building a system, let's say you're like, and route optimization is a very standard problem today because of all the delivery services we have. Everything is a delivery service nowadays. So and what are the parameters that they have to optimize for, right? Like some optimize for cost, some optimize for delivery windows, some optimize for what capacity do you have, and some optimize for driver schedules and what potential disruptions are happening or weather. Or there's a lot of parameters that in real world that can affect this thing, right? So you have to have a planning system that would balance the immediate needs with long-term objectives, right? Uh, so that's the key role of planning system. So we covered perception modules, which is like your input, and planning is like how do you and this is like the best way to build agentic systems is think like how an agent works. Like how would you do it, right? How would an agent do it? Or if you have to delegate someone to do it, what are the instructions that you give? What are the things that you give? And what is the level of intelligence that you assume? So you use all of those and try to build it, right? So that is part of the planning system, right? So you how do you plan? What are you planning? What is the problem that you have to solve, and what are the things that you're planning for? So planning engine generates strategies by sequencing actions to achieve goals. That's what it is. And the next part of an agentic AI system is decision frameworks. So what are decision frameworks, right? So decision frameworks is so you're planned, but at every step you have to make some decisions. The agentic AI system has to make decisions. For example, let's say loan processing agent, right? So what would they consider? They would consider something like credit scores. But if credit scores was the only criteria, it would be very easy, like to do the loan decision, right? But it's not in real life. It's not that. So you have to take into consideration what are the constraints of the system, what are the legal compliance requirements of the system. For example, there might be regulatory compliance, there should be fair lending practices, and your risk tolerance, right? And depending on how credit, like some people might target subprime, some people might target good credit history. So there are levels of risk, and also not everyone will have like a salary, right? Like, okay, this is my salary, this is my credit score. You're showing me your credit score, you're showing me your income, and based on that, I'm giving you a loan. No, but everyone's is not that simple. Some people are like business, some people are part of gig economy, some people are part of low income groups. Everyone has to be treated in a fair manner and make a decision on that, right? So there are decision frameworks that we need to build. Like decision frameworks ensure agent makes choices that are aligned with your core business and core values of the business, right? So they also have to assess the risk, They have to weigh the trade-offs and then align decisions with organizational goals and compliance requirements. So the third part is like when you're building a multi-agentic system is that decision framework. Okay. And then the fourth component is adaptive learning loops. Now you make decisions, but what if the decision went wrong? What decision worked? So you need to have a learning loop, and it's also part of us, right? Like how we as humans or how we as human agents work. Like we do something, it works, it's great. You learn a little bit. If it doesn't work, you learn a lot. So why it didn't work, and what are the next steps that you need to do? So that's a continuously improve your performance, and you need to build a loop that integrates your feedback from execution, and also that system should be able to learn from historic data and live data. So, for example, right, like if I talk about adaptive learning loop, a good example would be a marketing agent learns that email campaigns perform well on a Tuesday morning versus any other time for B2B clients, and they can automatically adjust. Or like a retail store can look at, okay, if I have a game around in this area, the retail sales will work great, right? So they're planning around it. So it's more like you are observing, like, okay, today the sales are good. Why? Was there any in today? Was there what happened? And is there a pattern? Like every Tuesday morning, there's something. There's a people rush, or like Tuesday, Wednesday, Thursday, people are doing 3 days of commute to work, so that's why my sales are increasing. Or is there a pattern there, right? Is there a game happening? And so that you can better get that feedback and do things, right? So those are these adaptive learning loops, right? I think. And then the other one is coordination models for multi-agent systems. So coordination models are, and by this time, I think you guys like have understood, like an agent AI system has multiple agents. There's no one single agent. There's always, like, there are multiple agents trying to do their portion of work. Like how I took the if you go back to the analogy of an executive chef who's running a high-end restaurant versus the individual chefs or cooks that are preparing individual line of dishes, right? There might be a pastry chef, there might be a non-vegetarian or specialty dishes chef. So there will be, like, how, depending on how that whole structure is laid out, right? So an agentic AI system will always have multiple AI agents. So when you have multiple AI agents, and whenever you are running a team, or it's kind of you're acting as a team. So what becomes critical is coordination models for those multiple agent systems, right? So how do you coordinate? So and there are different variations of it, and also it again depends on the system that we are implementing, right? And each business is different, each use case is different. As I said, a live chatbot or a virtual user assistant is different from a real-time self-driving car. So it all depends on what is the use case and what your priority is, right? Your real-time self-driving car, your topmost priority is always safety, right? So in a chatbot, you're trying to be accurate with the information, right? If you don't know, you have to say you don't know, or you need to escalate or to the handoff to other agents which are human in the loop systems. But also in this case, like, human in the loop is another aspect of it. That's part of every agentic system. I can cover that, but in this case, it's more like what's the coordination model? What's the driver for it, and all that. So there are hierarchical models, there are market-based systems, self-organizing frameworks. So different models, right? And I can walk through them quickly so that. Hierarchical coordination is it's basically agents are organized in levels, like similar to org charts. And depending on that, your strategies would be like traditional company, like a traditional company structure with clear reporting lines, right? So the top layer, the C-suite agents, like if you look at it like that, the C-suite agents set direction, middle management agents coordinate and operate, agents execute, and the other layers like execute the thing, right? So it's and this model is effective. Again, as I said, these were like depending on the problem you're solving, whether you're going with hierarchical coordination or how you are setting up that coordination between the agents becomes important. So this model is effective where roles and workflows are stable in large enterprises with compliance heavy environment, right? So the underlining word is compliance heavy. That way you always have a supervisory agent who is looking at things, right? If you look at it, a banking operation can have uh, executive agents who are setting daily risk limits, how much you can risk. Supervisory agents are monitoring what are the transaction patterns that are happening, any fraud links happening, and operational agents are like processing individual payments. Each level has clear authority. Each level has clear responsibility and ownership, right? So these are like these is the set of pattern that you can use for how you set up your multi-agent coordination, right? This is one pattern, and but this is, as I said, the case is like depending on the industry. And then the other one is market-based systems. This model mirrors how real markets work. Agents can negotiate for resources, tasks, or time. So this is more like your capabilities are limited. So you have to always look at you have to make decisions on your capacity limitations, right? So you're always prioritizing tasks in that industry. So those are the market based econ like systems. Like some of the examples on how what these systems would be are, I would say, smart manufacturing. In a smart manufacturing facility, production agents can compete for machine time based on order priority. Some orders might be like more important than others. Like if you have a premium customer, like their orders are very important. So you would prioritize their orders versus lower tier customers, because your premium customers might be the ones that you're giving you recurring business or that loyalty, right? Uh, Again, another would be like content distribution. Uh, Streaming service agents can bid for bandwidth. So they depending on who pays it, you can get. And even advertisement is one other thing, right? Like the your screen space is limited. How do you bid, right? So that's what it is in this thing, right? And I've been covering some of the real world applications all along. Just to summarize some of the real world applications is like uh, in supply chains, agent track shipments, optimizes routes. They can anticipate demand shift. This reduces delays and increases reliance. So these are different examples of how an agentic AI can kind of show how agentic AI is not just a theory, uh, but a proven enterprise ready approach. So some of this would be like pretty complex, right? But it's proven again, the risk tolerance, the compliance aspect of it, and and uh, and a good feature would be like escalating to human in the loop or HITL whenever the agent system needs that uh, needs a human to get involved. So those key characteristics, if you have, you can build good agentic systems. Right? So, for example, human in the loop is very important in the initial set of days when you launch an agentic workflow. So, for example, I can share multiple examples of where human in the loop is. When Amazon Go, or even for our matter, when we launched our cashierless version store, there's always a human in the loop who is observing how you do the transaction so that to get it accurately right? And over a period of time, it will get the percentage of transactions that go to human in the loop kind of reduce, and that's where the optimization or the fine tuning of the agentic workload that you build will happen. But in cases where like Amazon Go or cashierless store, we had a human in the loop. There's a set of people who are watching what customers work, what they're adding, but they're also comparing it to the actual virtual cart that we were building on the one side, and what the human cart is being built, right? So if the virtual card and the human card are the same, we're good, and we identify the scenarios and gradually move them from the automated order processing or transaction processing to a human in the loop. And the other human in the loop is like even like I don't know, there's a Waymo service in here in US. At one point in time, if you don't wear your seatbelt, what it does is it takes you, it moves out to the parking lot, and then a representative comes online and talks to you and says that if you do not wear your seatbelt, you have to get down, or like it will not move. The ride will end at that point in time, right? So there's an escalation that is happening to a human agent to kind of move it in that direction, right? So there's this whole aspect of human in the loop that comes into picture for agentic systems, but that's an implementation. People don't talk about it in these things, but it's an implementation mechanism, and it covers a lot of scenarios, and it enables you to learn a lot of things, right? So that's what they are. And then the other kind of things are like operational workflows are another set of things. How am I doing with time? Okay, 10:40. So there are other operational workflows that we can build. So there's the dynamic resource allocation, means agent can shift compute. So these are different variations of the same thing on how agentic AI systems can build operational workflows, right? So the other part of it is building an like an agentic system, right? There are different considerations that we need to look at, and it all depends on different industries, right? There are governance considerations, there are compliance considerations. So the way you look at whenever you're building agentic systems is like agents must be able to explain their decisions in business terms, right? So why an agent made that decision, what is the decision framework that they used, and how did they arrive at the decision? And LLMs are good at it. They'll try to explain the decisions if you ask them, and there are different variations of different models are being done to kind of set that up. So you can see different variation models, right? Like there's with Claude, there is Opus 4 model, which is an analytical model which tries to tell you the decisions. And again, different agents can use different models depending on the task. If you need a lot of thought process, like you need a lot of analytical model, so the Opus is trained on that. But just as a general purpose model, you can use Claude Sonnet 4, right? So depending on and they're also like, I think the way the industry will move, there will be specialty models that will be built based on large language models. That intelligence is there, but then they'll focus on specialization. And also like there will be a small language models, like eventually things will come into an IoT level model so that they can decide on things, but that's the way forward, right? So the other concept that we are talking about is small language models and not just large language models. Now coming back to this ethical and governance considerations, so agentic AI system should always be able to explain why it did of what it did, right? And then clear policies for agent behavior needs to be documented so that the agent is provided the context on how to do. Human oversight, humans remains accountable. That's what the functionality that I was talking about, human in the loop. Agents enhance them, do not replace human judgment. So the agents are always a co-pilot system. The pilot is still human in a lot of places, right? So that's fundamentally important. Even when Tesla kind of rolled out the self-driving module, they'll always hand it off to the humans, right? Whenever they need, so that the humans are responsible for it, right? So that's ethical and considerations, right? Now, what's the blueprint for adoption, right? If again, depending on where you are in your journey from an AI enabled, and today we have uh, uh, we have some roles, like the new roles are coming into picture, which is AI engineers. They are called AI engineers. These are not AI, like AI engineers are not like machine learning engineers. They are more like they know enough of the LLMs, like how AI works, because LLMs provided you with that capability of AI behind an API, right? Like they have APIs the AI part of it. So there's a new stream calling AI engineering, which is like more of towards software engineering side, but also enough you have enough knowledge on how LLMs work, what how do you handle the non-deterministic nature of it, how do you test LLM systems, right? So how do you test LLM systems, right? So they're called evals. How do you write the evals? Using LLM as a judge is another thing. So there's a fundamentally a new set of practice that is getting developed called AI engineering, and it's more it's not towards the model builder side. The model builders are very uh, like they are a separate group of people, very knowledgeable, very like they're math heavy. They're doing it, but also like using this model to build applications that have significant impact on enterprises or real life scenarios. Right? That's the software engineering side. But again, there are ways that you can build systems, or you have to build systems, and using human in the loop, the eval pipelines, LLM as a judge to test it. How do you ensure that when a model changes that your things are working, and how does escalations happen? How do you think that the model is? How do you know that the model is telling people what accurate information or not, whether it is deviating, not deviating, where does it get its knowledge? And there's a new like initially it was called like there was like again our industry goes with buzzwords. There was prompt engineering, now it's context engineering, right? It's at the end of the day it's the same. It's pretty much the same. Uh, Prompt engineering was how you are instructing the model. Context engineering is you have a limited context window, how you are swapping out the context and giving the model enough information so that it could make the right decision, right? And I don't know if anyone has played with the AI agentic tools from a development perspective, like Cursor, Windsor, or Claude Code. They are agentic AI systems, right? They are agentic AI systems. They decide, they prepare a list of things, they follow it through, they execute it. That's those are actually core AI agentic systems. Yeah. So how do you start adoption? You'd start small. You'd focus depending on where you are. Start with focused pilot projects, build modular and scalable. These fundamentals of software engineering remain the same whether you're building an agentic system or a software system. You always build small, you always evaluate it, or you're called unit tests, now they call evals. You always have to have telemetry, observing and monitorability, which is because as someone who has built multiple systems, and like good monitoring system and continuous feedback loops is uh, what enables you to build great agentic AI systems or agents versus they're just like moving from demo stage from a demo stage to a production ready workload. The key part is, do you have a good monitoring system, and do you have how do you have a continuous feedback loop? So you're continuously tuning it. That's what that what it makes a good agentic AI system, or you have the capability, or you're attaining the capability to build agents or build agentic AI systems, right? And again, we all have to embed governance and compliance, because your company name is at risk, the enterprise name is at risk. So all agentic workloads are all have to go through legal review, because unless the lawyers are confident, we are not releasing anything into the production, right? So they have to be comfortable with whatever we have built, right? So uh, and The way I would look at it is like agentic AI is not future technology. It's available, proven today. I can tell you, like, I can list 5 to 10 different agentic systems that we have. I mean, they're variations of the same thing, but different companies have done that, right? The key is thoughtful implementation. Again, you start small, you develop the capability, you adapt it with clear business objectives. You'll learn, like, you have to scale systematically. There's no shortcut to that. The competitive advantage goes to organizations that master this transition, right? So basically, the way you look at it is like organizations will adapt. Some are slow, some are fast, and different aspects of the business are adapting. Right now, some organizations are their internal dev workflows are adapting the AI agents like the Lincer, Cursor, Cloudcode, and significantly reducing their build time or the develop time or the time to get to market. So that's one implementation, one adaptation of an agentic system. There are other enterprises who are far in the game who are implementing like virtual agents that are doing their workload, and some are already there, right? Like leaders who are just initiators, like who are just adapting, testing the waters, so yeah, getting comfortable, and some are leaders, right? I think I have one thing I want to kind of go through from this aspect of it is like I would like to go through one system and take through like take self-driving, like because it's a well-known use case, and look at what these 5 different modules are and how do they like connect to that agentic system. That way, it gives you a good idea of where this whole structure or the framework is coming from, right? And how does that translate into a real world implementation that we could relate. So everyone knows like self-driving, right? Like there's a lot of self-driving going in around US here. Like Tesla has it, and in China there's BYD has it, and in here there's Waymo who kind of runs a taxi service on self-driving mechanism. And even Tesla launched its product in Austin, like self-driving cars, like from a rental, from a like an Uber kind of thing. Right? So let's look at that use case and see where these things fit into. And yeah, it like I'll do a quick rundown so that I'll have enough time for questions as well. Right. So perception modules, right? So for Tesla, what would be for self-driving? I would call Tesla self-driving. A lot of companies have done that. So perception modules, right? If you think from that, what are the perception modules or perception modules for a test agentic AI of self-drive, right? So the visual perceptions are like cameras, like each car has cameras. They detect lanes, markings, traffics, pedestrians, other vehicles, right? And then spatial awareness is LiDAR, like Waymo has LiDAR, initial Teslas had LiDAR, and we use LiDAR in cashierless store of ours. They're great at creating 3D maps and surrounding, detecting objects and the distances between those objects. So LiDAR, that's giving you, so one is visual, one is giving you that spatial awareness. Motion detection, radar tracks moving objects and their velocities. And then environmental context, GPS provides you location data, weather, sensors detect conditions, and and again, these are the external factors of it. But then the internal factors are like speed sensors, steering angle, fuel, battery levels, right? So all these sensors, all these perception, all these are input signals that are coming into the system, and so they are all like sensor fusion is happening. So if you take, I think if you take like Tesla's real-time processing example, there are 8 cameras in Tesla that are providing you a 360-degree view. The ultrasonic sensors for close range detection, radar for long range object detection, GPS and internet navigation, and internal and vehicle diagnostics. Right. So those things are there. Like the contextual understanding is the system doesn't just see a moving object; it recognizes it as a child, a kid chasing a ball, and it will see like, okay, the kid might run onto the road because he's playing, or he or she is playing, and so let's prepare to break, right? So to see the amount of things that the perception, that sensory fusion kind of feeds into to making that decision, right? And then what is the second point of an agentic AI system is planning engines, right? Uh, Planning engines are more like, okay, let's plan the optimal route from destination, from source to destination, considering what the traffic would be, how the weather would play out, and then that's at the strategy, that's at the overall level, right? And planning also can happen at multiple levels. So at the tactical level, so that's the strategy part, and at the tactical level, you're saying like, I will change a lane. I'm approaching a turn, which lane I am, right? I would change to the rightmost lane to take the right turn, or the leftmost lane to take the left turn, right? So that's the tactical plan. And then operational level is like, okay, when I accelerate, please take like actions like acceleration, braking, steering adjustments, right? But again, if you look at planning, you can go to different levels in there. Like there is a dynamic replanning object of it, like and see why agentic systems are important here. See the number of inputs coming in, see the number of decisions or things that you need to make. You will not be able to do it in a heuristic basis, right? That's where this whole AI comes into picture, because somehow we figured out the math of what does he do next, or what's the next token is, right? So if a road closure happens, traffic jam, emergency vehicle approaching, all these things, they have to train the system, or they have to make that system learn on what to do, right? And also like objectives would be different. Hey, can I minimize the travel time, minimize your toll costs, optimize your fuel efficiency? Those are the things that he has to decide. But again, not all will do all of that stuff, but those are the factors. If you see, that's where this whole LLM, like not LLM, not LLM is for enterprise, but agentic AI systems. Here, they're not using LLM. They have their own trained models that are making that decision, but it's a form of that, right? And then the third part is, right, like we covered perception, sensor fusion, all that sensors, decision framework, strategic, tactical, operational decisions that needs to be made, and all at every point you're making the decision, like doing the things, planning, sorry. And then the third one is decisions, right? What would the decision framework would we look like for self-driving use case, right? The decision framework would be like safety first. So avoid collision at all costs, follow traffic rules and regulations, right? So if you go with different structures, I was talking about decision structure. So like different, like you can, these are the constraints that you're putting on the system, and you're telling the system to make those decisions. You have to always avoid a collision, you have to always follow compliance, your rates safely, you optimize for certain things, right? So depending on that, again, some might be rule based, some might be ethical decisions. Rule based is like, if you detect a school zone, what's your school zone speed? So here it's 20 miles per hour, so you have to always go under 20 miles per hour. You hear the emergency vehicle sirens, right? Imagine this thing, like when you're traveling, you have to be context aware. You hear the emergency vehicle, you have to go to the rightmost lane, or wherever the shoulder is, and stop. And if there are constructions, you have to follow the construction signs. So you have to always be context aware, and you're making those decisions, right? And then adaptive learning loop. So in self-driving case, what are the adaptive learning loops would be like driving pattern optimization, environmental adaptation, and depending on your patterns, it will learn on how to improve things, right? And there's some part of it would be like real-time adaptation as well, like and I talked about real-time adaptation, right? Like if you see a construction, you have to go down. If you see a school zone, you have to go slow. So, and what happens if your camera lens are dirty, right? So you move to focus on relying on LiDAR, or you give it a handoff to the user saying, hey, my lens are not able to detect, you are the pilot now, you drive the car, versus it steering you towards there, right? And then what the execution systems are like if you see the execution systems, there's real-time control, there's steering, throttling, braking, signaling, all that stuff are executing. And then even execution, it's a combination of all these things. Then you're executing. Then you have core functions of executing, and also like there should be fault tolerance that human needs to be built in, human handover protocols, the hittle and the loop. So all these things are there that you need to do, right. So in conclusion, like why self-driving cars are a good represent an advanced agentic AI system, right? They're not a simple agentic AI system, not the ones that we can build easily. They have to be built with a lot of investment on all that stuff. Because why are there good and advanced agentic AI are like they're a goal-oriented behavior. They're not just following roads, but they are completing transport jobs that we have, right? We want to go from one place to another. So they're ensuring that they're taking you safely. They're autonomous in decision making. So they're making thousands of decisions per second. See the number of sensor fusions, all that context aware. The environmental adaptation. So they have to adapt to the environment. And then the different stakeholders that they have to consider, right? The legal, the comfort, the public, all the expectations, ethical and compliance, right? So this makes like agentic self-driving as a great use case for agentic AI systems, and there are multiple things. They're like we are building a virtual resident assistant. It's small. It's dealing with 3 agents now, but it's we're trying to build it using some of these principles, and there are other systems in the market, like the Cursor, the Cloud Code. They're all agentic AI systems. They're not just AI agents. They're agentic AI systems because they are making those decisions. They are doing a job for you end to end, and they are taking the necessary tools or necessary agents that are required. And then, so I would conclude this with that, saying agentic AI transforms enterprise operations. And again, like we are in the business of developing enterprise software. So agentic AI transforms enterprise operations by scaling autonomous and intelligent decision making. This session tries to offer you a clear blueprint on what are the things that you need to keep in mind while you're building agentic AI systems. Again, depending on where you are in your AI journey, where the organization is in your AI journey, but this is like significantly advanced systems there are. If you want to build it, you can leverage this set of framework to build an agentic AI system, right? That's all from my side. I have my LinkedIn URL. I'll take questions if there are any. Any questions? Anything?
Yes, I have dropped them in chat.
Oh, sorry, I couldn't. So for a student learning about AI, I'll read through the questions and I'll answer one by one. What is the simplest way to understand the difference between a normal AI chatbot and an agentic AI system? A normal AI chatbot is also an agent in itself, because right now the chatbots that we are dealing with are, at least if you're using the OpenAI or Claude, they're all very powerful agents because they have a lot of capabilities that are internally built and providing you as a product, right? So they are agents in itself. They are not agentic AI systems, but they are a good agent, AI agent, because they are able to handle, like, as I said, like when you are asking OpenAI some questions, it's going and searching the internet and trying to find you. So it's a tool capability. It's a AI agent call, right? But in the past, like if you are building, if in the past, if you had seen some chatbots or if you have had experience with chatbots, it was a rule-based thing. You had to train a lot of rules, and someone who has seen how they are built, there's a lot of rules, a lot of like training that needs to be done. That part is done right today. So, and the agentic AI system is, as I said, it's far more complicated than just a normal chatbot. I would say a chatbot is an AI agent with great capabilities, but agentic AI is this whole system. It's doing your job for you from that perspective end to end, right? So that's what I would say. The second question is, what are the most important skills we should learn now to be ready for jobs working in agentic AI in the future? I would say, I think the fundamentals of software engineering are still applicable. So who is having a lot of success with agentic AI systems are full scale engineers who can build both backend and UI and then understand and handle the complexities, right? So if you see there are two languages that are winning this aspect of it. There's Python. Uh, Again, if you have a full scale experience building applications in Python, but Python is more for from that machine learning standpoint, okay, and building the back end for the agentic AI system, right? The front end is again important as well from an application because when people they use it as a product. They don't use it as like just like a UI based from the HTML mechanism or anything like that. So I would say if you are already in software engineering, you already have a good head start. You start with understanding uh, what how to leverage these LLMs, make those calls. You have multiple frameworks. You can pick one depending on your language. If you are Python, if you have experience in Python, you are aware of it. You can go ahead and build, start leveraging different frameworks like LangChain or Agno is one more thing that I liked from Python's perspective. And there are multiple things. Even AWS has come up with a framework for strands called strands for building agents. The problem right now is when you're starting is which framework should I learn? There are so many frameworks in building an agent, right? So the way I would answer that question is take the problem first, and you can pick any framework. I would say like you have to start with one and build it incrementally, and you will understand whether the framework is helping you or not helping you, right? You can build, you can make that LLM call because LLM call is basically a continuous loop. Okay, it is just looking for a loop. If you build your first chatbot using the LLM, it's basically a loop, continuous loop that you're listening on. So once you do that, then as you scale, you will see that okay, I need to do this for every agent I'm building. Let me see if someone else solved that problem. Some solved it easily, some solved it in a different way, right? So it depends on that. If you are a TypeScript or a JavaScript frame background, AI SDK is a great SDK. Again, that's not a framework, that's an SDK. So it's just dealing with it's abstracting out your model calls. And I think there's Mastra AI is another TypeScript framework that does a lot of, but it leverages like give you the ability to build agents, right? You mentioned ethics and governance. Can you explain the simple way companies can make sure that AI is being fair and not biased? Uh, there is no simple way. I think, as I said, there are two parts to this I mentioned. One is ethics and governance is you have to have guardrails for your AI, and and you build enough evals into your system so that your AI is answering as you expected, right? Uh, so when you're building these systems, that's what the three aspects of it will help. One, you build guardrails. There's a guardrails that you need to train your or tell your model, these are your guardrails, these are your red lines, you should never cross them. And it doesn't. Okay? And then you ask it to explain its decision and put it in a log behind. And third is this continuous loop and like evals, right? Evals are your data flywheel that need to be built at least to handle the negative scenarios, right? Like if you build your evals in such a way that you are testing it with all your negative scenarios that it could go wrong, and get the response and use LLM as a judge to validate it. That's why you're building a full loop. It's not pretty straightforward building these AI systems as the complexity grows, right? Because dealing with dealing with the compliance is one of the biggest aspect of it, and all our use cases have to be vetted by our legal team, and the way that you gain confidence with the legal team is using the evals and build that loop in saying that, okay, these are the negative scenarios I'm giving it, and this is the response it's giving it, and bring it in front of them for careful review of it, right? Eventually there might be things where it can go wrong, but again, as you make it tell you why it made that decision, there's something in its knowledge that it is missing, so you augment it with the knowledge on it. So that's how you have to build it. If a student wanted to build a simple multi-agent project for the portfolio, what's a good beginner-friendly idea to start with? Multi-agent for a student, right? If you are a student, you're trying to build a multi-agent. I would say, can you build? I mean, you are always demonstrating some of these concepts. For example, I would say a customer agent that, and it depends on the industry, depends on the use case. For example, if you take a banking use case, right? So build, you need to, when you're demonstrating it, you have to show it in the UI. So you build it as a chatbot, right? A conversational chatbot, but not just, and behind the scenes, you're using agent, build a agent to get the transaction history, build a agent to ability to do additional actions on its behalf. Like, hey, I want you to print me my bank statements. I want 6 months of my bank statements, right? Or so that can be one agent who is doing it, and other agent can be like it is looking into your transaction history and asking you, and you can ask it to summarize, hey, how much did I spend on movies this month, right? Or what are my upcoming subscription charges, right? So it is that agent is going in, looking at your transaction history, and answering your question. So it's kind of your real-time virtual assistant for that scenario. If you take banking, if you take rental, leasings, all that stuff, there are different use cases. Similar. It's more like if you are a user, think in this aspect. If you are a user, when you want a virtual assistant, and maybe for students, it's a good use case to build a research agent, right? If you go to Claude and see how they build the research agent, you have a main, like you have a citations agent, you have a web search agent. So I would recommend you to read that how Claude built it research agent. So that's a multi-agent. That's a good multi-agent. And as a student, if you want to demonstrate it, you can use their framework and leverage it for your implementation, right? And then, what is a common misunderstanding people have about AI that you would like to correct? Okay. Okay, the common misunderstanding I would say is thinking that AI is always right, uh, and not AI is. You should always think that AI, at the end of the day, AI is mathematical calculations. It doesn't understand the intelligence. It has been trained on a set of data, and the data can be wrong, and or its conclusions based on that data can be wrong, right? It is not necessarily true that AI, and that's what the non-deterministic nature of AI is, right? AI will make mistakes. It's not that you have to. It's a helper, okay? You have to ensure, or you have to override it, or you have to be in control all the time. It's a great co-pilot, but you are in charge. So always validate, verify whatever it says, because it's just guessing the next token. Okay, and if you have seen how LLMs are trained, they're guessing the next token. What gets you most excited or optimistic about the future of AI? It kind of it's a tricky question. Uh, it gets me excited as well as a little uh, scared or worried in aspects of it, uh, because we are at just the beginnings of the AI, like AI, and if you see AI has been there for some time, right? Like Alexa was voice enabled AI. You had facial recognition. You had you have this whole machine learning on agentic AI, self-driving. So all of that is there, right? But what this part of AI enabled systems, what has brought into the mix is it's targeting it's targeting the knowledge economy. Okay, it's geared towards the knowledge economy on it, right? So so previously, if you had to write an email, you, like, some people do great, but it's also helping other people who can compose that, right? So that knowledge part, it has enabled a lot of people to get up to speed and gain those productivity things, right? But it's just the start of it. As I said, we are 2 years into this, and there are multiple use cases. Again, there are multiple failures. I've seen multiple failures as well in how AI is implemented. It's a learning curve. Uh, so I would say, like, in my experience, AI has fundamentally changed how things are going to be developed in future. And if you have played with cursor, if you have played with this thing, it's like it's going to augment you well if you are prepared for it, if you can leverage it, right? Like when Word and these things came, some people are very excellent with it, but this is going to be a productivity changer for certain people. But you need to be aware, you need to invest and set up your own system on how to leverage this AI. So uh, it we are just at the beginning. Fundamentally, the development or the workflows are changing. There are still areas that it's not being, like, all organizations are not embracing it at the same pace, so there will be leftovers. But whoever adapts and implements it, or leverages it, I wouldn't say implement it, leverages it, because again, they are co-pilot, they are not a whole thing in itself right now, and how it transforms. Uh, so I've seen website development or application development time decrease significantly with AI. So, and also, so the other side of it is like, okay, how does it impact the jobs in the overall knowledge economy, right? That's we are seeing some of its impacts, but we still need to reserve the judgment on how things are going to evolve. Like, all productivity gains in history have enabled other jobs to be created. Uh, so I'm hoping it will be the same. There will be a new set of jobs that will be created because there's the productivity gain that was introduced. But again, there's some irrational exuberance on some of these AI things. You can see that reflect in some of the valuations and all the hype that is going around. But it's a little early to kind of tell where we are going. So that's yeah. I think I've answered all the questions. Any other things?